Hello, hello. Happy Saturday, everybody. It's good to see you again here on Saturday Chat Live. I say it wrong every weekend, but that's part of the fun. Um, Again, we're going to try to keep this around 30 minutes. I'll take whatever questions you might have here in the chat, which I need to pull up. Comments, pull those up. If you have any questions, comments, feel free to put them in there. We'll keep this around 30 minutes. Like I usually say, sometimes it goes longer, sometimes it doesn't. But we'll just see. So obviously it is late June. July is kind of like the low season in education, obviously. There are, most people are out of school right now, summer holidays and breaks, so on and so forth. So not a whole lot going on in the education space this time of year, which is fine. But I'll just kind of let you know what I'm working on, where we're going from here, and the plans ahead, and I'll answer whatever questions. So let's see here. Oh, you're a hero. No, you are my hero. Trust me. All my viewers are my heroes. That's what matters. So thank you. Hello. Welcome. So what are we doing from here? The next little bit of time. So I am continuing to work on the multiple regression playlist. So I should have some time coming up next week after that. On that note, there will be no live stream next Saturday. It is July 4th weekend here in the US. So if you're in Britain, sorry about that, long time ago. But July 4th weekend here. So I'm going to take that weekend off and do some things around my house, just kind of relax and read, and going to meet my family on that Monday, do some things with them. So next week, I will be taking next weekend off, for a little R&R. I'm off work for 4 days as well, so I'm gonna just take that time to myself. All right, let's see what else we got going on here. Oh, I do not follow Euro 2020. Usually when the World Cup starts and everything, I might start watching a bit, but I unfortunately do not. I have not kept up with that. So I would just say this. I'll take the cop-out easy answer and just hope for good matches. How about that? Let's see here. That sounds good to me. So I'm not sure what that is, but I'll take that. All right. I'll get to some of the other questions that are stat specific here in a second, but I know a few more people are coming in. The count is going up, the number of people coming into the stream. So it's glad to see you all here on the Saturday. So if you're just coming to the stream, a couple of notes. There will be no stream next Saturday because it's July 4th weekend here in the US. I'm going to take some time off. And then I'll be back the week after that, hopefully, unless anything weird happens, which is completely possible. There are some other things I'm working on too, sort of just personally, that I think are important. I think we can all benefit from. And by the way, all your stats questions don't have to be about stats necessarily. Long as it's like a topic that's, relevant and not, weird, I'm more than happy to discuss world events, whatever else it is it might be you want to talk about. So Uncle Larry, greetings to you, Uncle Larry. Hope you are well. So there you go. Good to see you. What else we got here? What's coming up? Oh, so on like a side, like not statistics note, one thing I'm going to start doing is I'm going to start doing some journaling to keep track of my like thoughts and like daily progress just in general. I used to do that in the past, but I think it'll help me to stay more centered, more productive, keep me kind of on, my truth, so to say. So I'm going to start doing that, and hopefully that'll come through in my work. And hopefully you will benefit by me doing that. Reading a lot of books right now and so on and so forth. So I hope that turns out well as well. Let's see here. What do we got? Just came here to thank you for your ANOVA series. It was a great help. Well, thank you for that very nice comment. I appreciate that. And thank you for taking the time to watch. Time is your most valuable thing. We only get so much in this life. And if you spend some with me, then I appreciate that. Okay. So thank you very much. Let's see what else we got here. It's hard to know stuff like this when we get into these nooks and crannies. So a stats question, sample size of 5886, dichotomous outcome. So of course that would be a logistic regression problem with very few positive cases. That could be a bigger problem. Is it acceptable to do backward stepwise logistic regression to investigate predictors? Depending, I think the main issue here might be how many positive cases you have, because the number of labels or cases in that outcome variable need to be somewhat balanced. So if not, the algorithm, the model doesn't see enough of both cases. So I would maybe rethink your data set or sample that data set, depending on how many positive ones there are before you develop that model, because it might the outcome might be misleading. So I would actually start there. And then as I said, we'll do backward stepwise logistic regression investigate. There's nothing wrong. There's nothing wrong with that. So that I can foresee as far as the procedure goes. So I'm not exactly sure if I've ever done a stepwise or model building logistic regression, but I don't see why not. All right. Okay. What else do we got here? When should categorical variables be they're categorical? Rescaling categorical variables? During a modeling process, after encoded. Everything I've read and done says that any rescaling or any sort of transformations or anything like that should be done before they're put into the model. But could be wrong, could be different depending on your situation, but that's everything should be set and ready to go into the model when you start. Let's see here. Discuss true independence between two variables. True independence can mean a lot of things. So the two variables are independent. You can look at, in sort of a probabilistic way, or you can look at the correlation and say that they aren't correlated, or the correlation zero. So independence can mean a lot of things. It just depends on upon the meaning of that word in this sense. So there are different ways. There are actually tests of independence as well. So it just depends on the use case. Maybe if you have more information, just drop that in the chat, and I'll do my best to maybe follow up with that. Let's see here. What do we got? Stat series is superb. Cleared all my doubts. Well, hopefully not all your doubts. I hope whatever you learn from watching my channel actually opens up new questions for you. And then you can go explore those questions. Oop, my Alexa just went off. You explore those questions, and that takes you further down your path. So hopefully my videos and other videos you might have seen have answered some questions, but hopefully they spawned a few more to help you along your learning journey. But you are very welcome. Let's see. Yes, hope for good matches, Euro 2020. Can you have a brief summary of the AIC and BIC and how to interpret both of them? So what our viewer here is referring to is when we do best subsets regression, or actually any other sort of model building, but best subsets is usually where you'll see this. You'll have columns of different criteria, such as R squared, maybe adjusted R square, maybe the standard error of the regression, Mallows, C, AIC, BIC. What these are meant to do, these different criteria that people have come up with, are meant to select the best model. So AIC and BIC are two of those. So I will admit BIC, I haven't researched a whole lot. I have seen it in there. AIC is a relativistic measure between sort of models. And it's one of those situations where we pick the lowest value for the AIC when we're evaluating sort of each each model. For example, it's different in that mallows C, which you'll see in your stats output, in some ways that's easier to interpret because in standard multiple regression, the value of mallows C is just a number of variables plus 1. So the full model, let's say we have 5 variables plus the intercept or plus the constant in our model. When we put all the variables into that model, mallows C will be 6, like 6.00 even. That's how it works. So in that case, we pick the one that is closest to P plus 1 relative to the other models that are of that same size. That's kind of how we interpret mallows. So AIC is just the smallest value relatively in there. Okay. So you can look more into that. I'm actually going to make some videos on all those measures. So standard error, the regression. I just made the adjusted R-square one, mallows, AIC, BIC. There's also AICC, which is a variation of AIC. So we'll get to those in due time. That's kind of my goal this summer is to get through all those different measures of evaluating best subsets models. So you kind of know how to evaluate each one and pick the one that you want. And of course, I will add here that all these measures like mallows C, AIC, BIC, and stuff like that, you can't use those alone. You have to have domain knowledge, some common sense, maybe a theoretical background of the model you're trying to build, a realization of the assumptions that might be in there. Look at the variables that end up in the model and say, does this make sense? So it's just, you have to do more than just look at these numbers in the output. So always make sure you're doing that. All right. Ooh, got some questions coming in. All right. Ever have one of your ears go weird and you can hear your own voice inside your head like booming? It's weird. It's very loud in my left ear. All right. Let's see. What clustering methods are there for data sets containing categorical variables? Thank you. So I'm trying to think of a case. We usually do clustering with quantitative type stuff. So trying to think what would be a good clustering technique for categorical variables. We're talking about like a categorical dependent variable or categorical independent variables, predictive variables. So maybe elaborate on that for me, or talk about exactly what you're hoping or trying to do in that question, Mercurio. Mauricio. Sorry, I said that wrong. By the way, a lot of my viewers are from overseas, so if I happen to pronounce your name wrong, I'm terribly, terribly sorry. I do the best I can, but I don't always get it right, so I apologize if I happen to misspeak. Let's see. Harini, hope I pronounced that right. What stat test should be done if the population has both paired and unpaired data with a binary outcome as a dependent variable? Well, I'll start with the back end first. I'd have to really see what you mean by population data has both paired and unpaired. However, if the outcome is binary, the dependent variable is binary, then that kind of boxes you in to logistic regression in terms of in a regression sense. So now there are other machine learning type models that can be used with binary or any sort of categorical outcome variable, but in terms of regression, it's going to be logistic regression, which of course is one of the primary, if not, in my opinion, the best categorical machine learning algorithm, besides all the fancy stuff. So the binary outcome variable in this case is really the limiting factor in what you can do. So, but I might need to know more about that situation. All right, let's see what we got here. Bradley, good to see you, my friend. New to your stream, just started at MS Data Analytics. Awesome, congratulations. So, Bradley, congratulations on starting your MS in Data Analytics. You will have, challenges along the way. You'll have successes along the way, but please stick with it and, keep digging and keep going and you'll get through it just fine. So Your videos on multiple regression are amazing. Thank you very much. Much as I can, looking to do a career change in a few years. Awesome. Awesome. So yeah, analytics isn't everything now. So good luck with that, and let me know if there's anything I can ever do. And yeah, just keep at it. All right. Thank you for your awesome series. Clear all my doubts. You are very welcome. Again, I hope for whatever doubts it cleared, it spawned some new questions and areas of learning for you, and maybe piqued your interest into other areas of statistics and ML data science. So, you're welcome, but keep going. Keep going. All right. How can we handle null or NA values from a data set? I mean, is there any process except taking the average? There are many ways to interpolate missing values. There are numerous ways. So taking the average of that variable is one way. Taking the median of that variable is another way. There are actually ways to use that variable as a dependent variable and then try to predict the value of the missing variable based off of the other variables around it. So there, you can do that. Of course, you can just exclude them if you really want to. So there are different ways to handle missing values. It just depends on the application you're in, the field you're in, maybe whether or not you have enough data just to do without them. So if I had 10,000 rows in my data set and I was missing 9 values in a variable, I might just exclude them or run the analysis multiple times. So run it without those 9 values and just shrink my data set by those 9 rows. Or I would use the average, the mean, or the median, or something like that. So there are ways to get at those missing data. There's no right way necessarily. It depends on the application. But yes, there are other ways. There are other things you can do. Let's see. So after years, I guess somehow missed the topic of Poisson. Brief intro. So I do Poisson process. I'm not sure what that is referring to necessarily, but I do have a video or two on the Poisson distribution, which you might find helpful. But the Poisson process is something I might have to look into more about what you're referring to there. So, but there are at least 1 or 2 videos, I'm pretty sure, on the Poisson distribution. All right. Pranav, hey back. All right. Let's see. All right. I'm an MBA guy. I want to build a career in analytics. How am I going to start? So it really depends on maybe what your end goal is, but I think a good place to start is sort of in several fronts. I always recommend people that want to get started in this field are obviously you'll have to have sort of the math statistics sort of background. Also, I think the conceptual background of what these things are in analytics, but I also think it's very important to read and study the soft side. So I preach this every live stream, almost every time I get a chance, is that starting a career in analytics or data science, whatever else you're going to do, it's very, very important to read and study in that general field. So let's say you want to go into finance analytics. Well, the analytics and the computer stuff and all that, that's one thing, but pick up some books on, important financial events in history. Read biographies on individuals that have worked in finance. Read the newspaper financial pages every day. Those type of things are just as if not more important than the actual numbers and the software. So to be a well-rounded person in that field, I would do all of those things. Plus, it kind of breaks it up. Like you can do some analytics, like on the computer, and look at the output and try to solve that problem. But then you can do something else. Read a book or an article or something like that that's not numbers based, and kind of go back and forth. And the way my mind works as a learner is if I do sort of different things, what happens over time is all the connections start. Like I start seeing the connection between this, the connection between this, the connection between this. And then all of a sudden I have this really, really big picture. That also makes you a very attractive job candidate. So not only can you speak the language of analytics and know the algorithms and know how the computer software works and stuff like that, but you can also go into an interview, you can go in and have a discussion about the realistic world of, say, finance or some other business topic or whatever it is you're going to do. So I would start with all of that. Now, up front, it's going to be a lot of time investment, but I definitely recommend looking at whatever you want to do from all angles and approach it that way. All right. Let's see. Thank you. Eman from the Philippines. Thank you for your comment. Thank you for watching. I learned a lot from you, and I learned a lot from you too. So thank you for taking some of your time to watch the videos. Like, as I always say, that's the most valuable thing you have, and I appreciate you taking some time to spend it with me. So I hope it is valuable for you. Let's see here. Just trying to go through some of these here. Someone on my master's program asked how to do better in regression analysis and statistical modeling class, so I linked them to your channel. I appreciate that, Fred. Thank you very much. Yeah, one of the best things you can do for anybody's YouTube channel, including mine, is to share. Share with classmates. Like I say on my videos, share with classmates, colleagues, or friends, or anyone else you think might benefit from watching. So if you share, that helps us, and it obviously means you can talk with your classmates about certain things if you're all on the same page. So we appreciate that. Share them on social media, share them on LinkedIn. It really helps us, get the word out and things like that. So thank you, Fred, for sharing it. And I appreciate your confidence in my content to enough to share it with them. So let's see here. Healthcare profession. So my mother is a retired nurse, 40 years, a nurse for 40 years. So good for you. I'm planning to change my career into data science. What would be the hurdle that I would face in this transition? It's hard for me to know that based on your individual situation and the job market you're entering and where you're located and stuff like that. So it is hard. I would say think of it as a positive. So if you worked in the healthcare profession, you've probably thought about and had access to data of some sort, or you've made observations on your own. So think, if you've worked in healthcare, what have you seen? What data have you been exposed to? How has that helped your thinking? And then what problems have you maybe solved? And then as you go into data science, you can actually pull your experience into that data science realm, use it as an asset, use it as a positive to go into that career in data science. So it would depend on your previous education, your previous exposure and comfort with mathematics, with statistics, with maybe it's machine learning, with computer software, whether it's anything from as easy as Excel to something more advanced like R or Python or whatever else. So there might be a learning curve there. But I would just say it's really easy to become overwhelmed with all of that. So I would just either do a little bit of each at a time, or maybe pick something and study it for a while and then go to something else, and just kind of switch back and forth so you don't become overwhelmed. And that goes back to the point I was saying earlier, is that by learning a little bit of this, a little bit of this, kind of in a spiral fashion, you start to make connections between things. So that's kind of the way I learn best. Some of the best students, I've ever worked with, and some of the best colleagues I've ever worked with are learners like that. They will do this for a little while, and then they'll read a book for a little while, and then they'll do like a Udemy course for a little while, then they'll come back to this for a while. And what happens is all these connections start firing off between everything. So use your previous experience as a plus, figure out what you can bring from that. Also do a self-assessment of your own mathematical and computer skills in terms of the concepts. I recommend, depending on where you're at, there are lots of for beginners books and courses out there. Start there. A lot of them are taught very well, and they set that foundation for the more complex things you're going to learn as you go. So just like any other structure or building, start at the foundation, build a good foundation based off your previous experience and sort of the basics, and just build Just slowly build from there. And as you build, it will become solid and you'll have a firm structure of your data science career. So, and last thing I'll add to this, I think, which is important for everyone, a lot of people in here, is that the data science field and profession, depending on who you ask, some people think it's not, some people think it is a bit saturated right now. So you would want to think how you want to stand out. You want to specialize in something specific. Is there an area of opportunity in the field that you're interested in that can give you sort of that little edge? And also, since you're interested in it, it's something that you enjoy, where you can kind of fit in that nook and cranny, right? So take lay of the field, where you're at. You might also refer to individuals that help job candidates interview. So there are lots of questions about, there are also lots of guides about how to answer data science interview questions. Sometimes from those guides, you can work backwards. So you can look at some of those basic guides about interview questions and say, well, these are things that tend to come up. So make sure when I'm learning, I want to make sure I cover those things. And that's a very practical way of looking at it. So that was a very long-winded answer, but I do think it's important, especially like on my channel, a lot of individuals are in that sort of position, whether they're students outright or making career change, of how to approach that switch. So it's kind of an open, there are many ways to do it, but I generally recommend approaching it from as many different perspectives as possible because you start making those connections. So, all right. We are doing well. Does learning data structures help in data science and machine learning? Depends on where you want to go. So not all data science and machine learning positions or stuff like that require advanced knowledge of data structures. Others do. So it just depends on what you want to do. If you have an interest in it and can pick it up, then I would definitely at least learn some amount of it. It can't hurt. All it takes is time. So if you have the time and you have the interest, learn a bit about data structures because it is related, of course. But if it takes too much time, then I would focus on something else. It really depends on what you want to do and the jobs you might want to work in, so you're prepared for those positions. All right. Excellent, excellent, excellent. Thank you. You are very welcome. The thanks is all mine. What do you recommend between SPSS and Minitab? If those are the only two choices, it's hard for me to talk about SPSS much. I have not used SPSS in many years. So back when I was doing some graduate work many years ago, I used SPSS. I've used Minitab more recently, and I do like Minitab in many ways. But of course, there are many out there. I think in some ways, I think SPSS and Minitab, at least the last time I used SPSS, are similar in a lot of ways. So I would just pick the one that you're comfortable using, that's intuitive to you, that gives you the output you want. Maybe you will look into the fields you are currently working in or want to work in and see if there's a standard in that field about which one you should use. And of course, those aren't the only two. So there are many others, like JMP. So I kind of use JMP, JMP by SAS, primarily now. So I am not wedded to any software package. I use whatever software will help me solve whatever problem I'm working on. So if Minitab's best, I'll use that. If JMP is best, I'll use that. If Excel is best, I'll use that. If I need R for something, I'll whip that out and use that. So it just depends. But between those two, I know more about Minitab, so I can recommend that. All right. You are very, very welcome. You're welcome. Let's see. All right. Can I invest next 6 months in learning regression analysis only and still be able to get a prominent job as an ML engineer developer? And how important is it to learn different methods? So just learning regression will not be enough, I think, to get a prominent job as an ML engineer or developer. You're going to have to learn more of the algorithms. You're going to have to learn more when to apply certain algorithms, how to evaluate them. So whether that is you know, having a categorical or binary outcome variable or a quantitative one. You have to know that. You'll have to know the difference between supervised and unsupervised at the very least models, and beyond that. So learning regression will get you pretty far, but I don't think that would be enough for a prominent job as an ML engineer developer. That will require a lot more work, not only on the conceptual side, but also obviously on the programming side or whatever tool you're going to use. So, but regression's a good place to start because it is intuitive. It's easy to understand. It's easy to interpret. It is easy to set up. There's no black box that it's going on in. It's just a bunch of matrix algebra, basically. So start with linear regression. I would move on to logistic regression, and then branch out from there into different clustering and other supervised and unsupervised techniques and stuff like that. So that might be how I approach that. So start with regression, but then go on from there. Would be my my recommendation on that. All right. You are very welcome, Jeet. Thank you. Thank you for your comment. Let's see. For an imbalanced data set, which is the preferred evaluation metric, this is a classification problem. So I'd have to know more probably to answer this fully, but obviously if it's a classification problem, so the outcome variable is dichotomous or, has multiple levels, multiple categories, that will limit the type of evaluation metric you can use. So obviously if it's a classification type situation, then the confusion matrix will be something you look at to see how it classified your outcome variable. If you're doing an ML sort of situation where you're either doing a train test split like 70-30, or you're doing cross validation, and then you kind of check on whether or not the test set made good predictions based off the training set. But it would be something along the lines of a fusion matrix would be how I would evaluate something like that. For the imbalanced data set, if we're talking about the classification, the outcome variable being imbalanced. So sometimes these algorithms, well, I think most of them nowadays can be set up to be stratified to make sure that the outcome variable, that dichotomous outcome variable, whatever it is evenly distributed among either the folds in the cross validation or in just the simple train test split. So, sometimes you can just check a box and it will try to stratify that to make sure that the cases are representative in the folds or in the train test split. So, all right. All right. For beginner in statistics, which books, websites, or videos would I recommend? Well, there is this guy named Brandon on YouTube that makes stats videos. That's a good place to start. Then you have things like Josh's StatQuest is obviously an amazing channel. There are so many stats channels, and really it's just finding the one that you like, It depends on how you want to learn. There is no one way or right way to learn. Everyone approaches learning in their own way. Some people prefer to watch videos. Some people prefer to find textbooks and read textbooks because they are very structured and outlined. And sometimes they have problems at the end you can practice, Some people like Udemy if they want to try that sort of thing. So there is no one way. I think it's just kind of finding the videos or the books or whatever that you find helpful and just sticking with that. It's whatever way works best for you is the best one. Also, the one you'll stick with is the best one. So just search around. Some people like statistics for dummies. I have stats for dummies right down there on my bookshelf. Some people like to start there. Some people go to YouTube. Some people go to textbooks. There's no right or wrong. Just find the one that works for you. All right. Now, I will say one thing about my YouTube channel, and it's very on purpose. It's very purposeful. is that I try to approach things I focus on clarity and like the logical progression of how a video proceeds and making sure you know where everything comes from. So that's not for everybody, you know. I don't do anything fancy. I don't play music or anything like that. I just try to keep things simple and to the point and walk you through the examples of where everything comes from. And I also try to put it in the context of some sort of at least semi real world example the best I can. So that's just my style. And it's not for everybody, it's for some people. So again, find the videos or whatever else that work best for you, or books. Thank you. You are very welcome. Many thanks for all your videos. I've never found anything more helpful. Do you have any videos on simultaneous equation models? Thanks indeed. No, I do not have anything on that. As you have probably guessed, I've done some advanced things, but I tend to focus on the basic fundamental building blocks to prepare students for those more advanced things. Also, the reality is on YouTube is that it's better for people like me to spend my finite time making videos that benefit the most people. So, so my most watched video, of course, is the first video in my linear regression playlist. It has over 1.5 million views now. Well, why is it? Hopefully it's decent, but it's also the video that helps the most people. It's the broadest reaching one. So that reaches everyone from undergraduate students in their first stats class in their degree program. It even reaches some high school stats programs, but it also reaches individuals who are going into data science or machine learning. So it has a very broad audience base. So I can spend time making stuff like that that benefits the most people, or I can do something very specific and very niche, like simultaneous equation models, or, there are many other very, very specific things that would take a lot of time, but maybe not be as benefit to a large number of people. So I have to balance those things, between what is most valuable for people versus something very specific. Now, there are more complicated things and more advanced things I would like to get to, but I seem to never run out of the basic building block videos that I really enjoy doing for a lot of people. So, yep. So that's kind of my answer on that, at least for now. So I know I've had requests for like structural equation modeling, which I do find interesting. But again, that's a very specific thing when the audience is relatively small. So I just have to pick and choose which ones I do. I also tend to make videos on the same topic sequentially, as you've noticed. So I kind of pick a topic and just run with it as long as I can to its natural end. And then I decide what I want to do next. Because as you all know, by this point, YouTube is not my full-time job. I do have a 9-to-5 corporate full-time job. I have YouTube. I actually have a third job where I do voiceovers for training courses for public schools here in the U.S. I do that. So I have a lot of things going on, and I only have so much time. So I kind of have to choose wisely in terms of my time. But hey, if anyone wants to give me $250,000 to make YouTube videos, I can give you my bank account. So, of course, I'm just kidding. All right. Let's see. Good book for econometrics. Do I have it here? Pardon me disappearing for a second. Sorry. If I have this book. Where is it? Oh, here it is. Aha! I know I had it. So disclaimer is that I work for a higher education publisher. Of course, that means like software and stuff now, but we do make books still, of course. So, but I'm not saying this to promote this from that perspective. I'm just saying it because I know it's a good book. It's a popular book, and I like it too. So, Wooldridge is a good econometrics book. here. So I don't work on this book personally, but I know the people who do. It's a very, very, very good book. So you can maybe find a used copy of this one or something like that. So it's good, but it is a bit dense, and you do have to be comfortable with the mathematics, which I think if you're studying econometrics, you have to be. So this is a good book. There are others, but this is the one I have and I use as a reference if I want to look up an example or something like that. So it's Wooldridge for econometrics. Again, if you can find a used copy for a few bucks, then what's the harm? So try that one, see if you like it. All right. Let's see. Thank you. You are very welcome, VJ. Thank you for stopping by. Appreciate it. Let's see here. Longer question. Tutorials about two-way ANOVA groups were balanced, but what about unbalanced? Where different types of sum of squares are involved. So, yes, in a two-way ANOVA, it doesn't have to always be balanced or they have the same number of observation in each cell. Most of the times people do try to do that because several things happen. It's easier to understand and interpret if the cells are the same. So sometimes, depending on the situation, a researcher might sample data to make sure it is balanced. So they'll draw their samples to try to make sure it is balanced. So you can actually kind of engineer it being balanced if you want. The challenge with having unbalanced cells in a two-way situation is that you get into very complex, like you said, sum of squares, but also the degrees of freedom get very weird in that situation. So it can be done, but it will have to be done obviously using a computer because the math gets very weird. And you have to be careful of how you interpret the results in the end. So I always tell people in these sort of situations to try to keep them balanced or very close to being balanced. Because otherwise, the variance gets all weird. Because obviously, if you have more measures in one cell, that tends to decrease the variance, whereas if you have fewer in another, will tend to increase the variance. So just have to be careful with how it is set up. So yeah, people have asked this question before, and then of course, like all textbook situations for the most part, they tend to teach the most rosy, scenarios. So it is possible. You just have to be careful with how it's interpreted and set up when you run the output. So, all right, let's see here. About 15 more minutes if we have more questions. Let's see, Kaggle competitions or end-to-end simple ML projects. Which is better? Hard for me to say because I'm not a recruiter or I'm not hiring out in the field. But I would tend to think my general answer in these situations, as I've said many times on this stream already, is to pick the one that you will stick with and you enjoy. Or do both. So, what I would probably do in this situation, I would start with end-to-end simple ML projects. That's where I probably start. I might even use the built-in data sets that come with software and just get used to the intellectual and muscle memory of doing things, So get into that sort of groove, just starting with the simple ML projects and, how to set it up, how to run it properly, how to maybe solve different things on a small scale, like missing values or creating a new variable based on another variable or a combination of other variables. So keep everything small because the process is the same. So if I want to create a variable based on another variable or two other variables, something like that, it doesn't matter if I have 100 observations or 10,000 because the process is the same. So I would probably start small and look at all these, different situations and kind of learn those things in a small, you know, data set that doesn't freak me out or doesn't require a lot of computing power, stuff like that. And then build from there and just build up step by step and then get into things like the Kaggle competitions or whatever else you want to do or the Maven analytics type thing. So that's kind of maybe how I would start. But that's me though, right? Some people would like to dive right in to Kaggle competitions and it's like trial by fire, right into Dante's Inferno. Just jump right in. So it depends on what you want to do. There's no right or wrong. Thank you for that. All right. Thanks and greetings from Spain. I'd love to come to Spain someday. Would love to go to Spain someday. Good vibes. Yes. All right. Let's see here. What else we got? Thank you. Thanks for your videos. You're very welcome. Good vibes, of course. I like good vibes. So appreciate you, my instructor. I appreciate you. Okay. Trust me, I appreciate you as more than you could ever know. So thank you. Any website or courses that you would suggest to start from the basics and for data science? Again, this is anything from YouTube if you like watching videos, or you can find Udemy courses on sale pretty cheaply, like under $15. And Udemy is basically a data science site now. It's just flooded with so many of them, actually too many in my opinion. So there are so many there. And of course, you can look at the ratings and the comments to see which ones people really enjoy. So you can start there. And some of them, a lot of them have data sets you can download and follow along with or whatever else. And some of them have questions you can answer. I wish YouTube had an education specific feature where I could actually put questions at the end of a video or inside of a video or something. That would be amazing. So if you're a YouTube engineer and know someone who is, tell them to put that in YouTube education. So I could do it. Or find used books that people like. You can go on Amazon or any sort of other used bookstore and just search for data science, and you can look at the reviews, see what people like, and start from there. It's really up to how you learn best and how you want to start approaching it. So, and then your path will kind of go from there. But I always tell people to start with where they like to learn best and then branch out from there, All right. Let's see here. Is machine learning and data science two different streams or both meets together in one way or another? So there's that famous, sort of it's not a Venn diagram, but it's like a nested circles about how all these things with AI and data science and so forth. I do think they are related, but they are, in my opinion, two sort of separate things. I think machine learning is a very more specific thing that is a bit closer to statistics in some ways, whereas data science can be much broader, much more into the programming side of things and working with data structures. And some people will put, SQL inside of data science. So they're related, but I do think they're different. And I do think ML is a bit more specific, at least from my way my brain works, But if people do have some statistics background, I think picking up the basics of machine learning is a bit easier because you'll start to see some of the same things. You'll see root mean square error, in both. You'll see regression, linear and logistic regression in both. You'll see that. So there's a good overlap there. But I always have viewed data science as it's a much broader topic that can be a lot more things that does require a fair amount of coding background. All right. It gets confusing many times. Yes, it does. Let's see. Do you think adversarial machine learning is really a threat. I'd have to look up what you mean by that. If you're talking about machine learning algorithms that can be harmful, I do think that is a threat. Actually, I know it's a threat. Have you heard about any instance of machine learning applications having been abused? I could do a whole live stream on this topic, and maybe I will at some point. I think right now, maybe the biggest threat to civilizations are the ways our models and AI is being used to create surveillance states where everything we do is being watched, our faces are scanned all the time, where privacy will be a luxury going forward. So I think while it's not designed to do that, I think we're creating mass surveillance states with these things. That's one of my big concerns. And there are others. I have many concerns about how some of these things are applied, and I could talk forever about them, but I don't have enough time today. So I assume that's what you mean there. If not, let me know. But I do think these things can be threatening if we don't keep tabs on them, think about them, how they affect real people, and how they affect our human freedoms and rights. We got to be careful. All right. You are very welcome. You're very welcome. How can I take regression diagnostics and assumptions and consider with the general linear model? I'm not exactly sure what you mean by that question. I do have several videos that talk about the nexus between regression, GLM, even ANOVA, because like analysis of variance and regression are really cousins. They're two sides of the same coin. And actually, you can look at one. You could take a problem we think of as ANOVA. This is actually a good question about the ANOVA thing earlier. One way of approaching an ANOVA problem, analysis of variance problem, is just to turn it into a regression problem. You can do it. It's easy. You know, you just make columns for your variables. So, you know, you can do things that way. And there are other techniques. So I have several videos on GLM and sort of how everything fits together and how you can interpret the output and what this is saying, what that is saying. So that might be a place to start. But because GLM, you know, GLM is a big umbrella. It's a huge general linear model is an umbrella under which many things reside. So a lot of the assumptions and things are the same, and you'll see a lot of the diagnostic output that's the same between them. So the ANOVA table in actual analysis of variance, where you have like your F statistic and stuff like that, is really the same thing when you see the ANOVA table and regression output. And actually, if you do one as an ANOVA problem and one as a regression problem, you'll get the exact same table. Exactly. So start thinking about the relationship between those things and how different measures and how the setup is that, you know, correlates, for lack of a better word, between the two. So I hope that kind of answered that question. All right. A few more minutes because we're at 54. As a pure math grad transitioning into ML, do you have any book recommendations which are math heavy? So I don't have them down here, but the I think a good place to start at least is the 100-page machine learning book, which obviously is very popular, and the author just released a new one. I think it's like called Engineering. It's about data sort of engineering. They tend to be a bit more mathy in those. So the 100-page machine learning book. So I think So Andrew, I think is how you pronounce his name. I do apologize if I mispronounced that. So I would start maybe there with those two books. And then this is the old go-to that I always keep on my shelf. So this is the introduction, the ISL book. So the Introduction to Statistical Learning. Definitely has some mathiness in there. If you want to go sort of that route, if you are looking for like a more mathy statistics book, this one right here is a bit more mathy. It's the New Bold statistics book. It is definitely more on the what I would consider like the mathy side of things, if you want to approach it that way. And of course, there are even more advanced books that actually get into all the matrix algebra that underlies a lot of statistics and so forth. So, and then you have like the, all the Coursera courses that can get pretty mathy, so yeah, so you can start there. All right. Is it better to test for homoscedasticity and normality visually, like residuals, or trust the tests? Both. So since it's so easy to do nowadays, always do a residual plot to see if there is any pattern in the residuals, to make sure they are distributed evenly across, our observations. But you can also look at the tests too. So nowadays, because computers make everything so easy, I don't think there's any reason not to do both. So a lot of times you will want to include sometimes those residual plots in your report or whatever else you're doing, and sometimes the visual can show you things that look a bit odd or different that maybe just that one measure doesn't. So I always say both. All right. Let's see here. All right. To your videos, helping out my journey as a stock market trader. A book based on your videos. Well, a couple things about that. There are a number of books. There are many stats books already. Number one, any time I would take to make a book is any minute I would spend writing a book is a minute I can't make a video because there's only one of me. Two, on my website, for a few dollars, relatively cheaply, you can actually buy the PDFs that have the transcript and the slide images in them. So it's kind of like a book anyway, but the book is just the transcript of the video. So it's basically, in a way, it's not really a book, but it's like it's obviously the transcript. You can take notes in there and stuff like that. So there. Plus, in my current 9-to-5 job, I cannot write a book because I would be competing against my own company. So I couldn't do that anyway, unless it was like a, something not in higher ed or something like that, possibly. But it's probably best not to even go down that road. So mainly, honestly, it's just time. And I'm not sure me writing any sort of book would add anything. It would just take more time away from making videos, which is what I really love to do. So if you want the PDF and transcripts and you have a few dollars to help out me and the channel, it's on my website. You can always check that out. All right. Yoga. YouTube movie, and notice there's a ton of gibberish comments, my bots. Yes, all internet forums pretty much are run over by bots. That's the nature of the beast, unfortunately. Thank you for your answer. You're very welcome. You're very welcome. So we're almost at an hour, everyone. So if you have any last minute questions that have popped into your head, go ahead and put them in the chat and I will answer them the best I can for you. And some of these I don't really have an answer for. I have to go back and maybe look things up. So yeah, I will have to look some of these up to get a better answer. So any last minute questions? I'm going to go ahead. I will keep watching the chat if anyone pops in for a last minute question. But just a few reminders as we go forward. No stream next week. It's July 4th weekend. I'm going to take that weekend off for a little R&R. Just kind of recharge. And of course, work on some stuff too, but just mainly just take a break from everything for a weekend. I have some days off work during that time. So I'm going to use those wisely and see my family and stuff. And I will continue on the video series I'm working on about evaluating regression models. The best subsets like the AIC and Mallows and stuff like that we talked about earlier. So I am continuing to work on those when I have time. So, all right. Okay, everybody. So we're at an hour. I could keep going, but I'm going to go ahead and wrap it up here. So if you have any other things, just message me on YouTube. Well, you can message me on YouTube, but also LinkedIn. That's the only social media I have is LinkedIn and YouTube. I don't do anything else anymore. I deleted it all. So you can find you can find me there and just pop me in a question the best I can. Just keep in mind that I don't have a whole lot of time to answer specific questions about your specific case. It's really hard to find even 10 minutes. But I'll do if it's a quick question, I'll try to answer it. But if it's involved, I may or may not have time, so that's just the nature of free advice. But thank you all very much. And I hope you have a wonderful rest of your Saturday or Sunday, depending on where you're at. So happy trails and keep on learning, my friends. Take care. Bye-bye.